Hello students, we're back again, still continuing with the applications of linear propagation of light. We're going to look, the first one we looked at was a shadow, and we saw the different shadows. Then now let's look at eclipse, and we are saying that an eclipse is the obscuring of light from the sun by either the moon or the earth. So an eclipse takes place as a result of the sun, the moon, and the earth being in a straight line. There are two types of eclipses, namely, we have the solar, the annular, or sometimes it is called eclipse of the sun, and then we also have the lunar eclipse or eclipse of the moon. You shall see that under the solar eclipse, this is when the moon is between the sun and the earth. And here we have total eclipse of the sun, whereby the darkest part reaches the earth, that is the umbra, and then we have a region of partial eclipse, which is the penumbra, that is the solar eclipse. That is to say, solar eclipse, also called eclipse of the sun, it occurs when the moon is between the sun and the earth, such that both the umbra and the penumbra reach the earth. The area on the earth covered by the umbra has total eclipse, and the sun cannot be seen at all. So when it comes to the umbra, we cannot see the sun on the earth, so we experience the total darkness. Then the area covered by the penumbra has partial eclipse, and only part of the sun is seen. Then when it comes to the annular eclipse, which is under the solar eclipse, this one takes place when the moon is very far from the earth, such that a tip of the sun appears on the earth. So annular eclipse of the sun occurs when the sun is very far from the earth and the moon is between the earth and the sun, such that the tip of the umbra is the one that reaches the earth surface. From one place on the earth, the sun is represented by the appearance of a ring of light. So the distance between the earth and the moon varies slightly, since the moon's orbit around the earth is elliptical. Here it's like stretching a circle. The moon is like a stretched circle, or you can call it an oval. This explains the variation in the moon's distance around the earth. So that's all that we can talk about the eclipse of the sun. Make sure that the sun, the moon, and the earth are arranged in that order. Then when you're drawing the rays, you put the moon in the middle, the sun, and then the earth, because the earth is the biggest of all the three. When you're drawing the rays, you use a sharp pencil, and then you draw, first of all, you draw two parallel lines, one passing above the moon, and another one passing below the moon. Those two parallel lines are the one that form what we call the umbra, as you're seeing there. Then we draw other lines that are intersecting at a certain point, but one from below the sun passing above the moon, and another one above the sun passing below the moon, and those ones form the penumbra. So when you're drawing with your pencil, you can try to shade the umbra, and then you draw lines to make the penumbra. So that's how we can draw that. Then when you're trying to draw the annular eclipse, you try to make sure that the sun, or rather the moon, is far away from. Continue with the drawing. Then let's look at another type of eclipse, and that is the lunar eclipse or eclipse of the moon. In this one, the earth is in the middle of the moon, and then the sun. So lunar eclipse is also called eclipse of the moon. Lunar eclipse occurs when the earth is between the sun and the moon. During the eclipse of the moon, the earth's shadow is casted on the moon, such that when the moon is at position M1, as you're seeing there, position M1, it's above there, formed by the two parallel lines, and then those lines that were intersecting, that's where we find the position of the moon, M1. So in M1, then M2 is formed by the two parallel lines, that big circle, that is M2. So we are saying that when the moon is at position M2, total eclipse occurs. So M2, that's a region of total darkness. In position 1, partial eclipse occurs. And then when the moon is in position M0, that is M with a 0, that beyond the lines, no eclipse occurs, but the moon is less bright than usual. So that's all we can talk about the eclipse. However, the total eclipse of the moon takes longer than that of the sun, because when it comes to eclipse of the moon, it is the earth which is in the middle. And when you compare the size of the moon and the earth is bigger than the moon. So when we go to total eclipse of the sun, where the moon is in the middle, that means that the other one, which is bigger, will take long to rotate. Therefore, the earth, which is in the middle, is larger than the what? The moon for the sun. So that's the reason for, or as to why the total eclipse of the moon lasts longer than that one of the sun. I think normally we experience this, whereby there comes a day and it's during day, but you observe total darkness, and it takes some minutes. So that's as a result of the three. There are these terms that are used, which you'll be finding, and that is the fluorescence substance and then the phosphorus substances. A substance which absorbs energy and immediately releases the energy to form light is what we call the fluorescence substance. For example, we have zinc sulfide, the screen of a TV, the cathode ray oscilloscope are made of the fluorescent substances. I think all of you, when you're watching your TV, immediately you switch on, it shows you what to watch. So that one is it falls under what we call the fluorescence substances. When you continue with some other topic called modern physics, you'll look at the details of this. Then when we have what we call the fluorescence substances which absorb the energy falling on it, stores it, and when energy stops falling on it, it releases energy in form of light, e.g. calcium sulfide. These ones you will look at them in details when it comes to chemistry. So that's all that we can look at there. Then we have our last application of rectilinear propagation of light, and that is the pinhole camera. Look at that diagram very well. You observe we have an object, that is a light, I think it's a bulb. We have a hole which is called the pinhole, then it is darkened, then we have the image. What do you observe? You look at it. According to what I'm seeing, as if there is a difference between the object and the image. I'm seeing the object is facing up, then the image is facing down. Therefore, that image is upside down. In physics, that is what we call inverted. So when you try to measure very well the distances of the image from the pinhole and then the object from the pinhole, you'll observe that the image distance from the pinhole is smaller than the one for the object. Then that one makes, or we give it a term that the image is diminished. Then we have another one. When you're seeing these light rays, they are passing direct through the hole and going to where the image is formed, that is on the screen, and they are intersecting at a point that is at the pinhole. Therefore, that image is a real image. Shall look at the details of real images as we continue with this topic. So, the operation of this pinhole, an object is placed